just going to look at this idea of symmetry. Because if you know symmetry exists in a curve, it makes life a little bit easier when it's sketching, because you only have to draw half of it, if you like, and then reflect, or whatever the symmetry happens to be. So there's two types of functions that we're concerned with. There's the odd functions, first of all. And they're the ones, the formal definition, function negative x is equal to the negative of function x. So if we have to prove something's odd, that's what we have to prove, that relationship. Basically, visually, its symmetry is point symmetry about the origin. I suppose, more correctly, 180 degree point symmetry around the origin. So you can rotate it 180 degrees and it falls back on itself. So, looking at our four basic curves over here, we have some odd functions. Which ones would be the odd functions? Cubic would be an odd function. Rotate it 180 degrees, you would get the same shape. Hyperbola. That particular one would also be an odd function. Rotate it 180 degrees, you get the same shape. Any others? Did I hear someone say circle? No. Because in order for it to be an odd function, it first of all must be a function. And the circle is not a function. Okay. So spin it 180 degrees, it looks the same. So y equals x cubed, 1 on x, x to the 7 minus x to the 5, minus 3x to the power of 9 plus 2x. So they're all examples of odd functions. So when you're looking at polynomials, just look at the powers. The powers have to be odd for it to be an odd function. Unfortunately, that's not good enough for a proof, but I mean, if you're just looking at it, that's another way of telling. So all the powers are odd. So let's prove y equals x cubed plus x to the 7 is an odd function. So if they say prove it, okay, we know function x is x cubed plus x to the 7. Let's investigate function negative x. Now if I get negative x to the power of 3, I'll get negative x cubed. And negative x to the power of 7 would be negative x to the power of 7, which I can factorise to be negative outside of x cubed plus x to the 7. So yes, indeed, function negative x equals negative function x. Thus, it is an odd function. Even functions also have symmetry. They're the ones where function negative x is equal to function x. But it has line symmetry. So the y-axis is an axis of symmetry. You can fold it on top of itself. So now, looking over to the left-hand side, the even function would be our parabola, y equals x squared, because yes, it has the y-axis as axis of symmetry. What about the circle? No, you never fool people twice. Good. It's not a function, so once again. Okay, so x squared we said. X squared plus 4 minus 3x to the power of 6 plus 2x4 minus 27x squared. So if we consider 0 to be an even number, all the powers are even. So a constant number is an even function. Because if you think about it, it's just a horizontal line. And a horizontal line you could fold on top of itself. Let's prove x squared plus 4 is indeed even. So function negative x, well when I square negative x, I get x squared. So function negative x is the same as function x. Yes, therefore we do have an even function. That's it for today. Nice quick one.